Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers paper 3. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Question 2. E, the universal set, contains numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. A is a set of even numbers and B is a set of factors of 10. Complete the Venn diagram for this information. So we've got to put all those values from the universal set in the diagram, so all those need to go in. Now if they are even numbers, they're going to go inside set A. If they are factors of 10, they're going to go inside set B, and obviously if they're even numbers that are factors of 10, they're going to go in both. I think what I'm going to do, just before I start putting them in, I'm just going to list out what numbers we're talking about here. So even numbers are the numbers 2, 4, 6, 8 and 10 on that list, isn't it? And the factors of 10 are 1, 2, 5 and 10. They're the factors of 10. Okay, so which ones are on both? Can you see I've got like a 2 and a 10 on both? Okay, so I'm going to start with those. I'm going to put those in the middle. 2 goes in the middle, 10 goes in the middle. Okay, and then what else have I got? I've got then my even numbers that are not factors of 10 are 4, 6 and 8. So 4, 6 and 8. And my factors of 10 that are not even are 1 and 5. Okay, now have I got any missing? Have I got any missing from those? So just going to go through and double check my my universal set, make sure I've got them all. So I've got 1, I've got 2, not got 3, I've got 4, got 5, got 6, not got 7, got 8, not got 9, got 10. Okay, so those ones I got missing, 3, 7 and 9, they still need to go on the diagram, but they're going to go outside the two sets that I've got. So 3 goes here, 7 goes here, 9 goes here. It doesn't really matter where you put them as long as they're inside the square and outside the circles. Okay, so there we go. I think I've got all of them. I could just double check by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I've got them all. Right, now part B says a number is chosen at random from the universal set. Find the probability that the number is in the set A intersect B. Okay. So what does intersect mean? Intersect means and. So it needs to be probability that it's in set A and it's in set B. Okay, it's got to be, basically it's the bit in the middle, isn't it? This is the bit we're talking about. This is in A and in B. Okay, so the probability of A intersect B is the probability of A and B, which is how many values are in that bit in the middle. There are 2. How many values there altogether? There are 10. So my answer is 2 over 10. Hector can run 400 meters in 66 seconds. Use this information tool to show that he could run 5 kilometers in less than 14 minutes. So he can run 400 meters in 66 seconds. So what is his speed that he's running at then? We've been given this, which is distance traveled, and this, which is time taken. And I know a relationship between distance, speed, and time. Do you? It's a handy little little triangle. Distance, speed, time. Those letters are there alphabetically. That helps you work out what the equation is that links those three quantities. Now we want speed, which is down here, look, and that tells me that it's the other two divided by each other. So speed, or average speed, is distance traveled divided by time taken. So that would be 400 meters in 66 seconds. So calculator, what's 400 divided by 66? That comes out to be 6.06. Reoccurring 060606. I'm just going to round it off to 6.06. So that is 6.06 meters per second, isn't it? That's the speed they're traveling in. So if we know that that's the speed, and I'm going to be running at 5 kilometers, how long is it going to take me to run 5 kilometers at 6.06 meters per second? So then I want to find out time. So coming back to my triangle, if I covered up time, then it would be distance over speed, isn't it? So that's my next calculation I'm going to have to do. So time is equal to distance traveled over average speed. Okay, so now the distance is 5 kilometers. My speed though is in meters per second, so I'm going to convert that 5 kilometers to 5,000 meters and then divide it by 6.06. What's that going to give me? Well, I've got the last calculated value still is the answer. I'm going to use the full calculated value by using the answer key. So 5,000 divided by answer, that's giving me 825. What unit is that going to be in? I had meters and I divided it by meters per second, so that is going to be seconds. 825 seconds. Now, what's that in minutes then? To convert minutes, to convert seconds into minutes, I'm going to divide by 60, aren't I? There's 60 seconds in a minute. So 825 divided by 60 would be what? 13.75 mins. Now that's a decimal, isn't it? So what I want to do, if it was any other sort of questions, maybe convert into minutes and seconds. But here I just need to show that it's less than 14 minutes, which I've kind of done already. So I'm just going to finish off with that then. So I can therefore say, Hector could run it in 13.75 mins. Right, and it says Hector tries to run 5 kilometers in less than 14 minutes. Give one reason why he might not be able to achieve this. Well, fairly obviously that 5 kilometers is a lot further than 400 meters, and you kind of run out of energy after a while, don't you? You know, you can't run at a sprinting speed for 5 kilometers. You've got to go at a slower pace. So what I would say here is that Hector may tire and slow down. Right, 4.5 times 10 to the 5 is an ordinary number. Okay, so if I got 4.5 and I'm going to times it through by 10 to the power 5, that's equivalent of moving the decimal point 5 jumps to the right, isn't it? So it's going to go 1, 2, 3, 4, 5 jumps. So our decimal point is going to end up over here, which means I'd need to kind of fill in some extra zeros along the way in order that I can drop the decimal point there. So that gives me 450,000. The other way of thinking about it is 10 to the 5 is hundreds of thousands, so it kind of just translates your number into hundreds of thousands. Right, 0.007 in standard form. The way I do this, I just do it 7 times 10, and then I count the number of zeros I can see. So I can see 1, 2, 3 there. So it's going to be 10 to the minus 3. Okay, so 7 times 10 to the minus 3. Work out 4.2 times 10 to the 3 plus 5.3 times 10 to the 2. Give your answer in standard form. It's really easy with a calculator. Just have to type it in. So 4.2. You've got this exponent key down here with times 10 to the x written on it. So just press that, and then the only other thing you need to put in it is the power, which is 3. Okay, so 4.2 times 10 to the 3 plus 5.3. Type in the mantis apart. Press that button down there, times 10 to the x, and then tap in the power, which is 2. Okay, so what's that equal to? That equals to 4730, but remember they want it in standard form, don't they? Okay, so I'm going to have to rewrite that as the mantis apart as a number between 1 and 10. It's going to become 4.73. What's the power of 10? Well, the decimal point would start here. It's going to end up going 3 jumps to the left. So that is going to be times 10 to the 3 then, isn't it? So 4.73 times 10 to the 3. The diagram shows the results to the nearest percentage of a survey of 1,000 motorists. Driverless cars. Good idea, 20% think it is. Bad idea, 34% think it is. And not sure, 45% think it is. Interestingly, they don't add up to 100%, do they? Right, work out the largest possible number of motorists who thought driverless cars were a good idea. So actually, this is to the nearest percentage. It's a limits of accuracy question, isn't it? So if it was 20% to the nearest percentage, it means it's been rounded off to 20. Now, the next percentage up would be 21, and the next percentage down would be 19. So the ones that round to 20 are the ones that are halfway between those two. So the limits are going to be 19.5 and 20.5. They're the ones that round to 20 to the nearest percentage. So work out the largest possible number of motorists who thought driverless cars were a good idea. The largest possible is going to be the larger of those percentages then, isn't it? So I'm going to be using this upper limit then, 20.5, to calculate. Now obviously 20.5 you round up to the next value up, 21, but it still is the boundary and is still the one we calculate with. So largest possible is going to be 1,000 times by 20.5%, which is 1,000 as a multiplier. That's 0.205, isn't it? So that is 205. Now, strictly speaking, if it was 205 exactly, that would round up to 21% and not down to 20%. So I'm going to subtract 1 from that and write my answer as 204, because I know that definitely will round down to 20%. And the diagram shows a square-based pyramid and a sphere. The pyramid has a base length of 12.3 centimeters and a perpendicular height of 15.7 centimeters, and the sphere has a radius r. The pyramid and the sphere have the same volume. Work out the radius of the sphere. You must show your work in. Okay, we've been given the formula for pyramids and spheres, which is handy, so we have to remember them. Right, okay, so we know that these two shapes have the same volume, so these two things are equal in volume. Now we've got no measurements on the sphere, and we need to find out what r is. So we're going to deal with the pyramid first. Okay, so we're going to work out the volume of the pyramid, and then we're going to work backwards with the sphere formula to find the radius. Okay, so let's crack on with that then. So the volume of the pyramid is, what's that then? So the formula is down here. It's 1/3 times the area of the base times the perpendicular height. Okay, so 1/3 times area of the base times the height. Now This particular pyramid is a square-based pyramid. So the area of the base then is going to be this area here, whatever that is. And because it's a square, it's quite easy to find. That's just going to be 1/3 of the area of the base then is going to be 12.3 times 12.3, isn't it? 12.3 squared. And then the height is 15.7. 15.7. Okay, so throwing that into the calculator, we should be able to find out the volume fairly easily. So 1/3, I'm just going to divide everything by 3 at the end, I think. So 12.3 squared times 15.7 divided by 3. And that comes out to be 791.75 equals 791.751. Okay, and then what we're going to do now, so now we need to work out the volume, well, the radius of the sphere, don't we? So we know that the volume of the sphere is equal to 4/3 pi r cubed. Okay, so subbing in what we know that then that is 791.751 there. And we want to get r by itself, don't we, really? So we're going to have to rearrange this to make r the subject. Okay, so I'm going to multiply through by 3 and divide through by 4 pi basically. So I'm going to divide by 4 pi and times by 3, aren't I? Okay, and that will cancel those all out on the left and the right, and then I'll get 791.751 over 4 pi times 3 then, aren't I? Okay, so the 3 comes up and the 4 pi goes down, and that is equal to r cubed. Okay, and then so to find r, we're going to have to cube root that then, aren't I? If I cube root both sides, then I'll get the cube root of all of that. Okay, r is the cube root of 791.751 times 3 divided by 4 pi, all cube rooted. Right, so let's type that in. So I'm going to use the root sign first. So cube root, shift, there it is. Shift cube root. And then I'm going to use the fraction key. 791, well, it's actually my answer, so I'm just going to press answer, times by 3, and on the bottom I'm going to have 4 pi. Okay, what's that then? That's 5.7389. I'm going to round it off to 3 significant figures. I'm going to say r is 5.74. R equals 5.74. Unit, centimeters. So 5.74, final answer. Question 10. Eva writes 4 squared times 4 squared times 4 squared equals 4 to the power of 2 times 2 times 2, which is 4 to the 8. What is wrong with her method? Eva. I hope you haven't got your exam in a few weeks' time. Now, obviously, when you've got numbers with the same base and you multiply them together, you add the indices, you don't multiply them. So give the correct answer. Well, it should be 4 squared times 4 squared times 4 squared is equal to 4 to the power of 2 plus 2 plus 2, which is 4 to the power of 6. Describe fully the single transformation that maps triangle A onto triangle B. Now, A and B are different sizes, so it's definitely going to be an enlargement of some sort. Now notice that A is the larger one and B is the smaller one, and we want to find a transformation that maps the larger one onto the smaller one. So it's going to be an enlargement with a fractional scale factor. So we need to know what that scale factor is, and we also want to know where the centre of enlargement is. Now to find the scale factor, we just need to find two sides that are the same and compare them. So let's have a look at that side compared to that one. This side is of length 3, this side is of length 1. So my triangle B is 1/3 of the original height, or the original length. So the scale factor is going to be 1/3. The next thing we need to know is the centre of enlargement. Now the easiest way to find that is to draw on some ray lines that pass through matching corners of your shape. So let's draw one between those 2 points. And let's draw one through those 2 points as well. You can see that these ray lines are converging on the origin. I could draw a third one in as well, but actually I've already seen what the answer is. So they're all converging on this point here. So that's the center of enlargement. So to fully describe the transformation, I'm going to say that this is an enlargement with scale factor 1/3 and center origin. Here is a sketch of the line L, the point P at -6, 0 and Q at 0, 3 are points on the line L, and you can see they've been marked on the diagram. The point R is such that PQR is a straight line. PQR is a straight line, so in other words R is further along the line L. Okay, the point R is such that PQR is a straight line, and P to Q to QR, PQ to QR is in the ratio of 2 to 3. So for every 2 units we've got here, we've got 3 units up here then, haven't we? Okay. Find the coordinates of R. Okay. So I think all we need to do here really is to work out how far it is in this direction and how far it is in this direction. And then what we need to do is scale that up, don't we? And then we can use that to work out how far it is from here and how far it is to here, because they should be related by that ratio, shouldn't they? Okay. So how far is it in the direction of X, and how far is it in the direction of Y from P to Q? So if you have a look at the X coordinate of P, we're down here, look at -6, and then if you go to the origin, then you're going to be going 6 units to the right to get to the origin, so that's 6. And then to go from the origin 0, 0 up to Q, which is 0, 3, we are going 3 units up. Okay. Now the ratio of this to this, we were told, was in the ratio of 2 to 3. So if we take those distances and we divide them by 2 and we times them by 3, we should get the corresponding distances for the next bit from Q up to R. So if I take 6 and I divide it by 2, I'm going to get 3. And then if I times it by 3, I'm going to get 9. Okay, so if you think about it in the other way, if I've got the ratio of 2 to 3, if I've got 6, that is 3 times bigger than that one. So times that by 3, I'm going to get 9. Okay, they're going to be in the same ratio. So that must be 9 there. Okay, now if I've got 3 on this side and I want to know what it is on that side, that's a little bit trickier. Well, basically it's half that one though, isn't it? It's going to be 4.5 by just taking that and dividing it by 2, I suppose. We can do that, divide by 2. So and then I'm going to have, for 3 there, I'm going to have 4.5 here, which is kind of 3 halves of the previous one, isn't it? Okay, so how does that help us? Can we use that to find the coordinates then? I want to find the coordinates of R. So if I'm at Q and I'm at the coordinates 0, 3 and I go 9 units to the right, then my R coordinate then is going to be 0 plus 9. It's going to be at 9 there. Okay. Then for the Y coordinate, if I'm already at 3 here in the direction of Y and I go up another 4.5, that's going to take me 4.5 units above 3. That's going to take me up to 7.5. So my Y coordinate for R is going to be 7.5. So the coordinates of R are 9, 7.5. Right, and then part B says find the equation of the line that is perpendicular to L and passes through Q. Perpendicular to L and passes through Q. So the line that is perpendicular to L passing through Q is going to look something like this. Okay, now, and that's at right angle, isn't it? Now to find the equation of this line, Every equation of a straight line is of the form y equals mx plus c, isn't it? Now, I already know the y-intercept of this line because it's, well, basically it's here, isn't it? Okay, I know where it passes through the y-axis. It passes through it at y is equal to 3. So I know c already. C is equal to 3. Now, do I know the gradient? No, but I could find it, couldn't I? Because I could use the information I know about L to find the gradient of L, and then I could use that to find the gradient of the perpendicular line, couldn't I? So let's find the gradient of L. Gradient of L, which I'm going to call M1, that is going to be change in y divided by change in x. Okay. Now I'm just going to take the first triangle because the numbers are easier. So if you remember, it was 3 units up and 6 units along from P to Q. So the change in y, 3, divided by the change in x, 6, gives me a gradient of a half. Okay? So then the gradient of my new line, so the gradient of the perpendicular line, which I'm going to call M2. Now, the gradient of a perpendicular line is the negative reciprocal of the other line. So if I know M1 is a half, then I can flip that over. So half becomes 2 over 1, or just 2, and then I change the sign so it becomes minus 2. So my perpendicular line has a gradient of negative 2. I already knew the y-intercept was 3. So now I know everything I need to know for this line. If the gradient is 2 and the intercept is 3, then I can plug my gradient in there and I can plug my intercept in there, and then I've got the equation of the line. So therefore, equation of line is y equals m minus 2x plus c, 3. Y equals minus 2x plus 3. Sophia is competing in a long jump competition. Her first jump is 5.25 meters. Her best jump is 8% more than this. However, her best jump is 10% lower than the winning jump. Work out the length of the winning jump. So let's just try and visualize that. I've got a 5.25 was her first jump. Her best jump was 8% above that, but as good as that one was, it was 10% less than the winning jump. So that was her best, and this was the winner. Okay, so let's work out her best jump first off. So best is going to be, well, it's a percentage increase, isn't it? So using our triangle final original multiplier, our final is what we're trying to get. Our original is 5.25 and our multiplier is, well, it's 100% plus 8%, which is 108%. Which is 1.08 as a multiplier. So our final is equal to our original times our multiplier. In this case, the original was 5.25 times a multiplier of 1.08, and that gives me 5.25 times 1.08 gives me 5.67. So 5.67 is a very best jump. Okay, but the winning jump, well, this 5.67 is 10% lower than the original amount. So the winning amount is, well, the winning amount subtract 10% is 5.67. So I actually want to do a reverse percentage here. So for the winning one, our final is 5.67. It's her best one. Our original is what we're trying to find, and the multiplier is going to be 100% less 10%, which is 90%, which is 0.90 as a multiplier. So Using again the triangle final original multiplier. This time we are looking for the original, and we're going to use final divided by multiplier to find it. So that is 5.67 divided by 0.90, which is 6.3 meters, so 6 meters and 30 centimeters. That's a long jump. She's nowhere near it. Cool though. Question 12. The table gives information about the weekly wages of 80 people. And I've got 200 to 220, 250, which is 5, 252, 300 is 10, and so on. And it says underneath, complete the cumulative frequency table. Okay, so the first category, 200 to 250, is the same as the one at the top, isn't it? So this one is here. It's just going to be the same as that. It's going to be 5. Now the next category, 200 to 300, that involves these two categories here. So it's going to be the 5 and the 10 together, which is 15. Next category, 200 to 350, that includes this one as well. It's going to have to add on another 20. So that comes to 35. And we keep doing the same thing. We're just going to add the next one on to the previous one to find the next cumulative frequency. So the next cumulative frequency is going to add the 20, which is 55. Then add the 15, which is 70. And then add the 10, which is 80. Now it's a good idea at this point just to check your answer here, because they often tell you how many that you're expecting in the question. So you just need to double check your cumulative frequency matches up with the total you're expecting. Okay, so that's part A done. Part B, we need to then plot those values on the graph. Now when you're plotting the cumulative frequency curve, you are plotting upper class bound against cumulative frequency, not lower class or middle. Okay, so my first point, actually I can put one bonus point on. I can put 0 at the lower class bound of the first point. So I'm going to put like a cross at 0 to 100. Okay, because I've got nothing below 200. So then my next point is going to be at 250 as a height of 5. Okay, then after that I've got 15, a height of 15 at 300. So there. Then at 350, I'm going to be plotting 35. So there. And then 400 is going to be 55. There. And 70 at 450. And finally 80 at 500. Now it should give you a kind of familiar S-shaped curve. I'm going to actually join these points up in that curve. Okay, just as close as you can through each of the points. Okay, it should flatten out at the top. Okay, so that's my cumulative frequency curve. Finally, Julian says 60% of the group of people have a weekly wage of £360 or less. Is Juan correct? You must show your answer. So 60% of the group of people. What is 60%? 60% of 80. 60% of 80. Okay, what's that then? 100% of 80 is 80. 50% is going to be half that. It's going to be 40. And 10% is going to be 100% divided by 10, isn't it? It's going to be 8. So then 60% is going to be that one and that one added together, isn't it? 50 and 10 make 60. So 40 and 8 make 48. Okay, so 48 is what I'm looking up then on my cumulative frequency. So if I get my ruler out and then draw across from 48, change direction, draw down. Now I make that, is that 360? It looks about 360, doesn't it? I think he is correct. So that is 360 down there, isn't it? Okay. Is Juan correct? Yes, because, well, you know, it says show how you got your answer. See graph. Okay, because I've shown it graphically, don't I? I don't have to explain it all. So I looked across at 48 and I got 360, and that was the evidence I needed. So 60% of the group have a weekly wage of 360 or less. Then these people down here, look, this is the 60%, and they have a wage of 360 or less. So yeah, it's true. The number of goals scored by 20 players in the season is shown. So 0 to 4 goals 6, 5 to 9 goals 11, 10 to 14 goals 3, giving a total of 20. Okay, work out an estimate of the mean number of goals per player. Give your answer as a decimal. Okay, now this is group data. So in order to work out a mean, well, I can't work out a mean. I can estimate the mean though by estimating the number of goals between 0 and 4, coming up with a representative value. Okay, now what is the mid value of 0 to 4? Now, number of goals is actually what we call discrete data, so it's only whole numbers. So you know, if you hold up your hand and count 0, 1, 2, 3, 4, then you can see your middle finger is actually the 2, isn't it, of that. So the midpoint of 0 to 4 with discrete data is going to be 2. Oops. It's going to be 2. Okay, similarly with 5 to 9, if you hold up your hand and count 5, 6, 7, 8, 9, then your middle finger is going to be the 5, 6, 7, isn't it? It's going to be the 7. And then 10 to 14, 10, 11, 12, 13, 14. It's going to be 12 as the midpoint. Okay, so yep, they're the mid values, and then we can just multiply those together. So f, the frequency, times the mid value, x, gives us 6 times 2 is 12, 11 times 7 is 77, 3 times 12 is 36. So adding all those up, sigma fx, the sum of the frequencies times the values, 12, 77 and 36, what's that? 77 and 36 is 100, 113, plus 12 is 125 then, isn't it? So sigma f, sum of the frequencies, I've already been given here, is 20. So then the estimated mean is going to be sigma fx divided by sigma f. Okay, that's the official formula for it if you didn't know. 125 over 20. What's that then? 125 divided by 20 comes to 6.25. 6 1/4 goals. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Okay. Now, the most popular way for this to be taught, I believe, is looking at second differences and using a kind of a convoluted way of piecing those two together. So the second differences here, for instance, are going to be 11, 21 take away 38 is 17, 38 taken away from 61, that is 23, and 61 taken away from 90, that is 29. Okay, and then so that's what we call the first differences. The second differences are the differences of the differences. So you can see that's 6, 6, and 6. Okay, so normally when people are taught how to do this, they're taught to find the second difference, take that value of 6 and halve it, and then that is going to give you your n term, 3n squared. And then you have to work out the rest. You have to kind of then work that out and take it away and all that sort of palaver. But actually there's a different way that you can do it that I want to show you. Well, maybe let's just finish this method off first, and then I'll show the alternative way of doing it, which I think is nicer. So 3n squared. So if n is, remember this is when n is 1, n is 2, n is 3, n is 4, n is 5. Okay, so this sequence, if n is 1, 3n squared would be 1 squared times 3. It should be 3. When n is 2, 2 squared is 4 times 3 is 12. When n is 3, 3 squared is 9 times 3 is 27. And then 4, n squared is 16 times 3, 32, 48. And then 5 is 25 times 3 is 75. So then you work out the differences between your original sequence and this sequence for 3n squared. So what's that then? So the difference is 10 take away 3 is 7, 21 take away 12 is 9, 38 take away 27 is 11, 61 take away 48 is 13, and 9 take away 75, that is 15. Okay, so now what we've got left with, I hope you can see, is a linear sequence. So this has got a common difference this time. It goes up in twos, 2, 2, 2, 2, which means it's got to do with 2n. Okay, but it's not quite 2n, is it? Because 2n would be 2, 4, 6, 8, 10, and we've got 7, 9, 11, 13, 15. And that is 5 more than 2n. Okay, so then we combine these 3 bits together to work out that the nth term then of this quadratic, therefore nth term is 3n squared plus 2n plus 5. Okay, so now the reason I'm not so fond of this method is that, you know, why 3n squared minus, do you even know why you have to halve it there? It's just kind of learning a way of doing something. You don't really understand why it is what it is. Okay, well, that's the reason why I don't particularly like it. So we're basically teaching students how to do something. We're not teaching them why. When we're teaching this method, they rarely understand why you have to take the 6n, the common difference and halve it, and that gives you 3n squared. They don't really make the connection. So I tend to teach it a different way. I use it with the general forms of a quadratic. So if it's a quadratic sequence, then the general form of a quadratic is an squared plus bn plus c, isn't it? That's the general form of the quadratic, okay? Where a, b, and c are some constants, okay? Now, when n is 1, that's the first term of our sequence, isn't it? So when n is 1, then an squared plus bn plus c, I'm going to have 1 squared times a, that's a, plus 1 lot of b, which is b plus c, okay? And I know that that is equal to the first term of my sequence. It's actually equal to 10. Okay, now when n is 2, then an squared plus bn plus c, an squared, take n, 2, and square it, 4. I'm going to get 4a plus bn, which is 2b plus c. That is equal to my second term. That is equal to 21. Okay, and then when n is 3, n squared is 9, so that would be 9a plus 3b plus c, and that is equal to our third term, which is 38. So what we do instead with this, we kind of, and that's, you just kind of stop there. What we're doing is we're forming 3 simultaneous equations in a, b, and c, which we can then go on and solve simultaneously. Okay, now you might think, oh, simultaneous equations is horrid. Why on earth would we do it this way? This is really complicated. But actually, this bit here is the same no matter what sequence, quadratic sequence you're given. You always get this. So the only thing that you have to do is kind of bolt on your extra terms that you've been given from the actual sequence to form your equations. And then the technique becomes very similar. So after you've done a few this way, it comes really, really easy. Okay, so I've got 3 equations in 3 unknowns, a, b, and c, which I'm going to go on and solve. So the first thing I'm going to do is going to take equation 2, and I'm going to subtract equation 1. So equation 2, this one, subtract equation 1, which is this one. So what's 4a plus 2b plus c if I take away a plus b plus c? So kind of taking those away, I'm going to get 3a plus b, and the c's are going to cancel, so I'm going to get 3a plus b, and that is going to be equal to 21 take away 10, and 21 take away 10 is 11. Okay, and then I'm going to do the same thing. I'm going to do equation 3 take away equation 2. So then I've got equation 3 is this one, equation 2 is the yellow one. So taking the blue one, yellow one away from the blue one, so then 9a take away 4a is 5a, and 3b take away b is b, and 38 take away 21 is 17. Okay, so now I'm left now with two equations in two unknowns. Okay, so that's my second step. And now what we're going to do is we're going to take one of those away from the other. So that's going to be in my equation 4 and my equation 5. And now I'm just going to take 4 away from 5. So equation 5 take away equation 4. What's that then? So equation 5 then is this one. Equation 4 is this one. So if I'm taking equation 5 and I'm subtracting equation 4, what do I get? That's going to give me 2a is equal to 6. So a is 3. Once I know a, I can then sub it back into one of either 4 or 5 here. So 3a plus b is equal to 11. So 3 lots of 3 is 9. 9 plus what is 11? That tells me b is 2. Okay, and once I know b, then I can sub all those back into the first equation. A plus b plus c is 10. So a plus b is 5. And then what do I have to add on it to get 10? It must be 5, so c is 5. Okay, so they're my solutions. A is 3, b is 2, and c is 5. Then going back to our original form, a squared plus b, an squared plus bn plus c, just got to sub those values in. Therefore, nth term is equal to 3n squared plus 2n plus 5. Okay, so this draws on your knowledge of solving simultaneous equations. You might think, ugh, that looks hideous, I don't want to do it that way. But I would recommend giving it a go, because it's always the same. When you're doing this, no matter what quadratic you're doing, you'll find that 90% of the method is the same for every question, and you just get quite good at doing it. Okay, so try it. I'm not saying you have to do it this way, but I'm saying I think it's a better method, and students who do learn it this way tend to do quite well at it. So yeah, give it a go. Or not. Make f the subject of the formula. Now you need to take care with this one, because actually f appears in two places. It's down here and up here, so it's one of the hardest sorts of rearrangements that you need to do, and it's going to involve some extra steps. Right, so the first thing I'm going to do is I'm going to cross multiply the denominator. So I'm going to multiply through by this bit down here. So I'm going to multiply both sides by f minus 4. So if I times f minus 4 on both sides, f minus 4 times that, it's going to cancel with that one, and it's going to leave me with d lots of f minus 4 equals 3 lots of 1 minus f. Okay, now multiplying out the brackets, that's going to give me df minus 4d is equal to 3 minus 3f. Okay, so I've got f's on both sides. We're going to have to get all the f's on one side. So I'm going to add 3f to this side and to this side. Okay, so it gets rid of it there. And that's going to give me df plus 3f minus 4d is equal to 3. And then I'm going to do the opposite of minus 4d. I'm going to add 4d to both sides. Okay, so then that cancels with that. And it leaves me with df plus 3f equals 3 plus 4d. Okay, now notice I've got an f in both of these expressions. I've got an f there and an f there. That means I can factorize out the f. And that's going to give me d plus 3 in the bracket equals 3 plus 4d. And then finally, I can divide both sides by d plus 3. And so then that will cancel with that. And it'll leave me with f on the left-hand side. And I'm going to get 3 plus 4d over d plus 3. So the trick of these ones, when you've got f appearing in two different places, you want to try and collect them all on one side and either, collect like terms or factorize out the f out of the various terms if you've got other things multiplied by it. Okay, job done. The ratio of number of boys to girls at a party is 3 to 4. 6 boys leave the party. The ratio of the number of boys to girls at the party is now 5 to 8. Work out the number of girls at the party. Now, the ratio of boys to girls we're given as 3 to 4 to start with. But notice in the second part we're given the ratio of girls, well, the number of parts of girls is 8, which is twice as much as we've got here. So in order to compare the two more easily, I can scale up this ratio by a factor of 2 and rewrite it as 6 parts to 8 parts. Okay, so we're told that 6 boys leave the party. And then we've got a new ratio of boys to girls of 5 to 8. Now, notice that this 8 here and this 8 here are the same. So the number of shares for girls is the same. And the boys has gone from 6 to 5. So it's reduced by 1. So overall, we've reduced the number of shares of boys by 1 when 6 boys left. So I conclude from that that 1 share is equivalent to 6 students. So if we then take our ratio of boys to girls and times it up by a factor of 6, we'll find the number of students of each type overall. So 6 times 5, there should be 30 boys, and 8 times 6 should be 48 girls. So we need to work out the number of girls at the party, which is this number here, 48. Girls at the party, 48. Question 18, OABC is a trapezium. O to A is A to B is B, and O to C is 3 lots of B. D is the point on OB such that OD to DB is in the ratio of 2 to 3, and E is a point on BC such that BE to EC is in the ratio of 1 to 4. Work out the vector D to E in terms of A and B. Give your answer in its simplest form. Okay? So I was just checking as I was reading through that. All of that is already on the diagram, isn't it? You've got O to A being A to B being B, and O to C equals 3B. That's all on the diagram. Now, the other bits, the ratio is not, though. So O to D and D to B in the ratio of 2 to 3. Where is O to D? So O to D is there, and D to B, well, it's just a continuation, isn't it, to there. That is in the ratio of 2 to 3. Okay, so I don't know how long O to D is, but if you divide it by 2 and times it by 3, you would get D to B. And then B to E to C is in a ratio of 1 to 4. Where's B to E? So B to E to C, that is in the ratio of 1 to 4. Okay? I'm sure that's going to be very helpful. Work out the vector D to E in terms of A and B. So where is D to E? So I need to work out this vector. Okay. So we need to go via vectors that we know. And we don't know anything about anything on O, D and B and B, E and C. So we're going to have to go around the other ways. So what I think I'm going to do is I'm going to say, well, I've got this point here O and this point up here B. Okay. Now I can get from O to B along routes that I know about. I can go via A, can't I? So I can go around that way. So I can go from O to A and then from A to B. O to A we know is A. A to B we know is B. So O to B must be A plus B. I just want to express b to c as a vector. Now I can get all the way around from b to c as well via lines I know about. I can go back this way, down here and along here, can't I? Okay, so what's that then? That is b to c. I can say I go from b to a, then a to o, and then from o to c, can't I? That will take me there. So b to a, that's minus b. A to o, that's minus a. And o to c is 3b. So collecting like terms, that is 2b minus a then, isn't it? Okay. So I've got o to b, which is a plus b, and I've got b to c, which is 2b minus a. Okay, now we want to go from d to e. That's the vector we're actually trying to find. Now if you look at it, d to e is a fraction of o to b, which I know, plus a fraction of b to c, which I know. So I'm going to go from d to b, then I'm going to go from b to e, using fractions of those two vectors just found, using the ratios that we've got there. So I can say then that if I want to go from d to e, that is the same thing as going from d to b and then going from b to e. Okay, but d to b is a fraction of o to b, isn't it? What fraction is it? So I can see from the ratio that o to d is 2 and d to b is 3. So altogether that's 5 parts, and the d to b parts is 3 of those 5 parts. So d to b is 3/5 of o to b. So d to b is 3/5 of o to b. Similar reasoning from b to e. We can see b to e is a fraction of b to c. It's in the ratio of 1 to 4. So if you add those together, you can see that b to c is made up of 5 parts, and the b to e part is one of those 5 parts. So b to e is 1/5 of b to c. Okay, so what have we got then? Running out of space. I might need to push this up a little bit, give myself a bit more room. So 3/5 of o to b, that's 3/5 of a plus b, plus 1/5 of b to c, which is 2b minus a. Okay, so multiplying out the brackets, that is 3/5 of a plus 3/5 of b plus 2/5 of b minus 1/5 of a. I think you're going to have to budge up a little bit more. And that is equal to, well, let's collect like terms. I've got terms in a. I've got 3/5 of a minus 1/5 of a. So that is 2/5 of a. And then I've got 3/5 of b plus 2/5 of b. So that makes 5/5 of b, or just simply b. Okay, so I've got 2/5 of a plus b. That's it. That's my vector. Does it get any more simple than that? Don't think so. I think that's going to do. Okay, on to circle theorems. A, B, and C are points on a circle. CD is a tangent to the circle. And we need to write down the size of angle X and give a reason for our answer. Okay, so here's angle X. It's the angle between the tangent and the chord AC. Now, because I know my circle theorems, I've easily spotted that because this is a tangent and this is a chord drawn at the point of contact, and this is an angle subtended off that chord in the alternate segment, then I know that that angle there is the same as my angle X. That's the alternate segment theorem in action. So I can just say that x is 65. So x is 65 degrees, and the reason is the alternate segment theorem. That's just enough. Just writing that down as the reason is good enough. 20. This shape is formed from a rectangle and two sectors of circles. Points A, B, and C lie on the straight line. Angle CBD is 35. D is 5t, and EF is 2t. Now, before you do anything, just check all the information on in the question that's in written form is on the diagram. So angle CBD is 35. It's there. Look. DE is 5t, whereas that's over there, and EF is 2t. That's also on my diagram. So everything's on there. Always good just to double check though, because sometimes it isn't. Part A says explain why BC equals 2t. Give reasons for each step of your explanation. Okay, well BC, where's BC? BC is that length there. Now BC is the radius of that sector BCD there, isn't it? Okay, so it's the radius of that sector, but also this is also a radius of that sector, isn't it? Because yeah, from the B is the center of the circle then, if that's a sector. So those two lengths have to be the same, and that BD is they're going to be the same as this side here, isn't it? Because they're opposite sides of that rectangle. So I need to put that down in words. I'm going to say that BD equals EF, which is equal to 2t, because they are opposite sides of a rectangle. And I can say that BC is equal to BD, which is equal to 2t, because they are both radii, it's the plural of radius, both radii of sector CBD. Okay, so they're my 2 marks. So just stringing those two thoughts together. And then part B says show the perimeter of the shape is 23 over 12 pi t plus 14t. Okay, so quite a complicated perimeter. It's got BC I've already marked. It's the radius of that sector, which I know is 2t. I found it earlier. Let's write that in. Okay, then I've got this side here, which is going to actually be the same as this side, which is going to be the same as this side, isn't it? It's going to be 5t. That's going to be 5t for the same reasons that BC was 2t. And then so what we really need to do is to find those two arc lengths, don't I? I need to find arc length CD and arc length AF. All the others I seem to know now. So let's find arc CD first. So that is arc CD. This part here, look, that's the arc of this sector, which has got a radius of 2t and an angle at the center of 35. So it's going to be the angle at the center, 35, over 360 times. So an arc is a fraction of a circumference, and the formula for a circumference of a circle is 2 pi r. So 2 times pi times the radius, in which in this case it's 2t then, isn't it? Okay, just combining all those numbers in the numerator. 35 times 2 times 2, double 35 is 70, and double it again is 140. So that gives me 140 over 360 lots of pi t. Okay, so that's arc CD. What about arc AF? Well, we need the angle at the center of AF first. What's the angle there? Now remember, angles on a straight line sum to 180, and I know that that one there is 90. So then this angle here then is going to be 180 degrees minus the other two then, isn't it? It's going to be minus the 90 and the 35. So 90 and 35 together is 125. Take it away from 180. That gives me a 55 degree angle. So that one there is a 55 degree angle. So now we're ready to work out the arc length of AF. Now we know that angle. So it's going to be equal to the angle at the center, which is 55, divided by 360, because there's 360 degrees in a turn. And then multiply again by the circumference formula of a circle, which is 2 pi times the radius. And the radius of this one is 5t, isn't it? So again, just collecting up all those numbers in the numerator. 2 times 5 is 10. 10 times 55 is 550. So that's 550 over 360 lots of pi t. And then so the perimeter is going to be all those sides added together then. So I've got my two arcs, which are 140 over 360 pi t, plus the other one, which was 550 over 360 pi t, plus we've got two green lines and two blue lines, haven't we? So we've got plus 5t plus 2t plus 5t plus 2t. Okay, so this bit here is the pink bit, and then this is the purple bit down here, which we calculated here, which I've written here, and then I've got two green lines and I've got two blue lines. That's where my perimeter comes from, all the bits. So then adding that all up then, so the 5t and the 2t and the 5t and the 2t, that just sums to 14t, doesn't it? That's the easy bit. And then adding those two fractions together, notice they got the same bit at the end, pi t. So I've got 550 over 360 and 140 over 360. So if I add the numerators together there, that's going to give me what, 690 over 360. So I'm going to get 690 over 360 lots of pi t plus the 14t. Now we're almost there. Just that 690 over 360, that can simplify. So just typing that into your calculator to simplify it. 690 over 360, what does that come out to be? And that's 1 and 11/12, or you could rewrite that as 23 over 12, couldn't you? So that's equal to 23 over 12 lots of pi t plus 14t. Now, luckily, that's exactly what we were meant to get, 23 over 12 lots of pi t plus 14t. So we seem to have done it. It's correct. So we get to finish off the paper with a 5-mark algebraic fractions question. What joy. Okay, so we've got a complex looking pair of fractions multiplied together, and we need to show that it simplifies to a slightly nicer looking algebraic fraction. Okay, so we know about how to combine two fractions together normally. If I have a much simpler fraction like a over b times c over d, we would just say that, wouldn't we? We would say AC is equal to BD. We'd just multiply the top with top, bottom with bottom, and then we'd see if we can cancel anything out. That's exactly what we're going to do here. We're going to put all of this over into one fraction and then see if we can cancel anything. Okay, so let's start with 2w plus 4 over w squared minus 25 times w plus 5 over w squared plus 3w plus 2, and that's going to equal to something all over 1 divisor. So 2w plus 4 times w plus 5 over w squared minus 25 times w squared plus 3w plus 2. Now, can we cancel anything here? Just having a look at what's on the bottom of this, I've got we've got two quadratics on the bottom. Now, the one on the left, this one here, is actually the difference of two squares, w squared minus 25. If if you remember your identities, then a plus b times a minus b is equal to a squared minus b squared, which is what we've got going on here. So that part there becomes w plus 5, w minus 5. The other side of it, this bit here, is a quadratic. Can we factorize it? So does it factorize into two brackets? Well, if it did, it'd have a w and a w there. I have two numbers that multiply together to give me 2 and add to 3. So w plus 2, w plus 1. And that is over w plus 5 that we can't do anything with, and 2w plus 4, which we can do something with. So this part here, look. So that bit was that bit there. That bit was that bit there. That bit stayed the same, and the 2w plus 4 can become, or we can factorize 2 out of that, and it becomes 2w plus 2. Okay, so that's the blue bit. So we've kind of gone through and we've done little bits to each of those expressions. So now what? Can we cancel anything top and bottom? So I've got a w plus 2 there, which I can cancel with that w plus 2. And I've got a w plus 5 there that cancels with that w plus 5. So they all disappear. So that leaves me with 2 over w minus 5, w plus 1. Okay? So what we've done so far is we've multiplied these two things together. Now we still need to multiply that expression with this other bit on the end here, that bit. So that's the bit we're going to do next. So 2 over w minus 5 w plus 1 times 3w squared minus 16w plus 5. What's that equal to then? Well, that is 2 lots of 3w squared minus 16w plus 5 all over w minus 5 w plus 1. Now, it would be very handy if that top quadratic 3w squared minus 16w plus 5 would factorize, and I can then cancel it out with another one of my factors on the bottom. So does that break up into two brackets? Well, if it does, it's going to have a 3w here and a w there, and the numbers are going to have to multiply to 5 and add to minus 16. So if we put a minus 5 in there and a minus 1 in there, then that kind of works, doesn't it? So 3w times the minus 5 would give me minus 15w, and the minus 1 times the w would give me minus w, give me minus 16w altogether. So that does work. Right, so then can we cancel anything now? Again, I've got a w minus 5 there and a w minus 5 there, so they can cancel each other out. And I'm left with, what's left? We've got a 2, we've got a 3w minus 1 over w plus 1. Now, is that of the right form? Let's have a look back. Show that it simplifies to aw plus b, cw plus d. We're almost there. I think what it wants then, to make it into that form, I just need to multiply out the top part. Seems a bit counterintuitive, but let's do it. 6w minus 2 divided by w plus 1. Now that seems to be in the form. Question 21. The graph of the curve with equation y equals f of x is shown on the grid below. On the grid above, sketch the graph of the curve with the equation y equals f of minus x. Right, now this is one of our transformations of curves that we need to know about. There are 6 altogether. We need to know 2 translations, 2 stretches, and 2 reflections. Now this one is one of the reflections, isn't it? Y equals f of x goes to y equals f of minus x. Okay, what we're doing here is we're switching the positive x values for the negative x values, so that has the effect of flipping the graph, reflecting the graph in the y-axis. Okay, so if I reflect this graph in the y-axis, so let's take the discernible points on my graph, like those points there that lie on the coordinates. I'm going to take each one of those and reflect it. Okay, now the point at minus 4, 2, that's going to reflect over here to 4, 2. The point at minus 3, 0 is going to go to 3, 0. And then the point, oh, there's another one there I can do. I can do that point there at minus 2, 1. That's going to reflect over to 2, 1. And then I've got one at minus 1, 2, which is going to go to 1, 2. And then that one's going to reflect onto itself. Okay, so they're the points that I need. So after I've done those reference points, it's just a matter of then joining them up to get my solution. Okay. Now for part B, it says the curve C with equation y equals 5 plus 2x minus x squared is transformed by the translation to give curve S such that the point 1, 6 on C is mapped onto 4, 6 on S. Find the equation for S. Okay. So this point here then, 1, 6, is mapped onto this point here, isn't it? Okay, now that is a translation, isn't it? It's been translated 3 units to the right. Okay, so f of x goes to, it's a translation of 3 units in the x direction. Now if I pull back up my handy list of all the types of transformations there are, you'll see that for a translation of 3 units in the direction of x, that is f of x goes to f of x minus k. Okay, it's for k units in the direction of x. So that means this one is going to go from f of x to f of x minus 3. Okay, so this is f of x goes to f of x minus 3. Translation of 3 units to the right in the direction of x. So my equation for C going to S then, my equation for C was y is equal to 5 plus 2x minus x squared. That is going to go to y is equal to 5 plus, now rather than having x, we're going to have x minus 3, and minus, rather than having x squared, I'm going to get x minus 3 all squared. I'll just budge this over because I think it might be falling off the edge. So y equals 5 plus 2 lots of x minus 3 minus x minus 3 all squared. So basically every time we saw x in here, look, which is here and here, I'm going to replace it with x minus 3. So the 2x became 2x minus 3, and the minus x squared became x minus 3 all squared. Okay, so then all we got to do is then kind of simplify all that out then. So multiply out the brackets and recollect all the like terms together. So I'm going to get 5 plus 2 lots of x minus 3, that's 2x minus 6 multiplying out the brackets, minus, I'm just going to do the quadratic underneath and then deal with the minus sign afterwards. So I've got x minus 3 times x minus 3, haven't I? Which is 5 minus 6, that's minus 1, isn't it? So that's 2x minus 1, just collecting those 5 and minus 6 together, and then minus whatever this bracket is multiplied out. That's going to be x squared minus 6x plus 9, using that handy identity for perfect squares I was talking about earlier. And then removing the brackets, 2x minus 1 minus x squared plus, because minus and minus is a plus, 6x minus 9. Okay, so what's that then? So I've got a term, one term in x squared, so that's minus x squared. I've got some terms in x, 2x and 6x, that makes 8x. And then I've got minus 1 and minus 9 making minus 10. So minus x squared plus 8x minus 10. Okay, so that is my equation for S then. Y equals minus x squared plus 8x minus 10. Now I just checked the mark scheme and it looks like they gave full credit for this one up here. So actually all this down here was extra work in that wasn't necessary. It does actually say an equation rather than the most simple equation, which is probably, I was just thinking that I needed to tidy it up. So yeah, I just spent a bit more time on that one than I needed to. You could have got all the marks for just saying y equals 5 plus 2 lots of x minus 3 minus x minus 3 all squared. So that was fun though, wasn't it? Question 24. The flight of a plane was in 2 stages. The table shows information about the flight. So the first stage of the journey, the distance travelled was 731 miles, the speed was x, and the time in hours was 731 over x. And then in the second stage, distance was 287, speed was x over x minus 24, and time was 287 over x minus 24. Okay. In total, the flight lasted 2 hours. Work out the value of x. Okay, so most of that table we don't need then, is it? The distance and the speed have been used to calculate the time. Time is equal to distance divided by speed. So you can see the first 2 numbers here and here just end up being here, and the same with the second one. Okay, so they've just used kind of the DST triangle to work those out. So actually we don't need to know that bit at the beginning. All we need really is the last column of this table, this bit here. We know that the total the flight time lasted 2 hours. So what we need to do is to say, well, I've got 731 over x, and I've got 287 over x minus 24, and I know that this is equal to 2 because it's 2 hours. Okay, so what we then need to do is work out what x is from that. So what we've done here is we've formed an equation in x, and this equation so what we've done here is we've formed an equation in x, and that equation involves some algebraic fractions that we're going to have to deal with. Okay, so first off, when you're adding fractions together, you need a common denominator, and we're going to form that common denominator by multiplying x and x minus 2 together. It's a bit like if you had like halves and thirds, then the common denominator would be 2 times 3, it would be 6, wouldn't it? So here I've got x and x minus 24, so the common denominator is x minus 24 in the same way. Okay, so how many times does x go into x times x minus 24? It goes in x minus 24 times. So I'm going to have to take that 731 and multiply it by x minus 24, and then that's going to be added on to, how many times does x minus 24 go into x lots of x minus 24 times? It goes in x times, so that's going to be 287x on the top. Okay, now if you find fractions really, algebraic fractions really difficult to follow, just write some fractions down and have a think about what you do with those. Algebra is just generalized arithmetic. So whatever you do with numbers, you just do the same thing with algebraic terms. So just try that out. All right, so then on the top here, I've got 731 lots of x minus 24. So I'm going to just multiply out that bracket there. So I'm going to get 731 lots of x minus, what's 731 times 24? 731 times 24, that's 17,544. 17,544, okay? And then plus 287 x, and that's all over x minus 24, okay? And that's equal to 2, okay? Now the next thing I'm going to do is I'm going to cross multiply this up here, okay? Just multiplying through both sides with x minus 24. So that's 1018x minus 17544, and that is going to be equal to 2 lots of x minus 24, okay? So then I got to do some FOIL on the, well, then I got to remove the brackets on the right hand side there, haven't I? So that's going to give me on the right, I'm going to get 2x squared minus 48x. And on the right, I've still got 1018x minus 17,544. Okay. Now I want to try and get everything on one side, and it makes sense to collect it on the right hand side because that's where my 2x squared is positive. So I'm going to subtract 1018x. I'm going to add 17,544 to both sides. So these two things here are going to budge over to the other side, aren't they? They're both going to go over there. So that's going to give me 2x squared, and then I've got minus 48x, and I'm going to be taking away another 1018x. So 48 and 1018 together make 1066. So that's going to be minus 1066x. And then I've got plus 17544, and that's all equal to 0. So now I've got a quadratic, haven't I? Okay. Now notice I've got a 2x at the beginning, so I can make things a little bit easier for myself just by dividing through by 2. So that's going to give me x squared minus, what's half of 1066? That's 533, isn't it? So 533x plus half of 17,544. 17,544 divided by 2, that comes out to be 8,772. And that's equal to 0. Okay? Right, so now ideally I'd like to be able to factorize this, but I've got a very big number there, haven't I? I've got 8772. So to break 8772 down into all its factor pairs, that's going to be a pain. But I really don't want to do the formula because that's even more of a pain. So how can I make this a little bit easier for myself? Well, I could express 8772 as a product of its prime factors, because I've got a key on my calculator that does that. So 8772 shift fact. So that's 2 squared times 3 times 17 times 43. 2 squared times 3 times 17 times 43. Now this gives me some factor pair choices then, doesn't it, that I can possibly make. So if for instance I picked that 17 in there, that looks about the right sort of size, and I did, well, what's 8772 divided by 17? Then that goes with 516. That's quite close, isn't it, to 533 I'm seeing in the middle. So I'm thinking that's probably my my best bet. So 17 times 516, so if I did 8772 and I wanted to know its factor pairs, then 17 goes with 516. I think that's going to be my choice. So it's positive on the end and negative in the middle. That means my brackets have both got a minus sign in them. One of them is going to be 17 and one is going to be 516. Just double check, does that add up to 533? Yes, it does. So awesome. So x minus 17, x minus 516 seems to work. So then that tells me then, and that's equal to 0. So that means that x is equal to 17 or x is equal to 516. Now, do both those solutions actually work though? Now, if x is 17, if you have a look here, if you have a look at x minus 24, now if x was 17, then x minus 24 would be a negative number, which means our plane would be flying backwards, and that is not a good look for a plane. So I don't think this one is a possible solution. I'm going to say not possible, as x minus 24 is less than 0. Okay, so that one's that's not a possible solution. So the only solution is that one, x is 516. Therefore, x equals 516 what? Miles per hour. Okay, I am done. That was quite hard work. The equation of a curve is y is equal to x squared plus 14x plus 52. By completing the square, work out the coordinates of the turning point. You must show your working. Right, so if I want to take y equals x squared plus 14x plus 52 and rewrite it in completed square form, I take this number here, the coefficient of x, and I halve it, don't I? So 14 divided by 2 is 7, and that is then the thing that I use in my bracket. So y is going to be equal to x plus 7 all squared. That is going to be my replacement for x squared plus 14x. But x plus 7 all squared is actually x squared plus 14x plus 49. So I've introduced 49 more into my equation than I had to start with, so I need to take it away. Plus I've still got that 52 there left over from earlier that I didn't use. Okay, so then just tidying that up, y is equal to x plus 7 all squared minus 49 plus 52 is plus 3. Okay, so when is this equation at its least? It's at its least when this bracket here is 0. So then we've got 0 squared, and that occurs when x equals negative 7. So turning point is going to be when x is minus 7. Now if x is minus 7, that bracket would disappear and it would just leave you with 3. So y is equal to 3. Okay, so then the coordinates then are negative 7, 3.
Mr. T, he's the best.